done a lot of work on blue carbon, and then, you know, more recent years I've become really interested in restoration. So this is a little bit of a putting it together, and it's actually a very informal talk because there's lots of things that I'm still working out about this as well. So I'm always interested in your feedback. But I thought I'd start by just giving the Blue Carbon 101 for those of you who aren't very or haven't been very engaged in this, which of course is probably most people. But blue carbon in its broadest sense is basically all the organic carbon found in the oceans. And I mean, this term was coined because it sounds cool, of course, but really it was coined to bring attention to the important role that oceans have in regulating the CO2 in the atmosphere, and just how important healthy marine ecosystems are for that job that they do for all of us, right? So it is you know, a marketing term, really, if you like, but it really is to sort of try and focus people's attention on how important these ecosystems are, and particularly coastal ecosystems. So while it was sort of like blue carbon's all the carbon in the ocean, we really focus on these three systems, which is seagrass, mangroves, and salt marshes or tidal marshes. These are plants that grow in the intertidal zone and also subtidally for seagrass, and they're able to tolerate salt water and inundation, even though the salt marsh and mangrove plants actually have a terrestrial origin. So they have this really specialised suite of characteristics. You know, the huge root systems you can see there, and they're growing in anoxic, so low oxygen sediments, right? So they bring lignin and all these compounds that are really carbon rich into the marine environment, where they don't decompose. They decompose very, very slowly because there's limited oxygen in these anoxic soils. And in addition to that, all of that structure traps stuff that arrives in the tide, you know, and that also contributes to this accumulation of organic matter. So we focus on these ones because there's this really strong evidence, and you can see it in the soils. This is an example. You see it in the soil that there's this massive sort of carbon store in lots of these locations. So this is a site in Belize that I worked at some time ago, and this is the top of a 10-metre pile of organic carbon that's mainly comprised of red mangrove roots. So this is sort of like these, you know, really great examples of the fact that these things really do accumulate carbon, and on a per hectare basis they accumulate much more carbon than many other ecosystems on the planet. So I actually dug this photo out because it was actually one of my first forays into blue carbon research, and it was about trying to capture how much emission of CO2 goes on when you destroy these ecosystems. So this is an illegal clearing on this island, and I was just pretty pissed off about it. So the only thing I could do at the time was to go and actually measure the carbon dioxide that's being liberated, because the trees are not there, and this mass of carbon that's in the soils is beginning to decompose. So that's not the only reason, though, that we're interested in these ecosystems. And probably I would say, you know, in many cases, the bigger interest is in all these other ecosystem services that these ecosystems provide. So I'm focusing here on mangroves because I'm just basically mangrove centric, but you know, these same principles apply to seagrass and salt marsh ecosystems as well. So they're, you know, important nurseries for fisheries, and there's great evidence that shows that when you destroy your mangroves, you're actually going to lose your artisanal fisheries. They are important culturally. Really, a lot of non-forest timber products come out of mangroves, as well as timber products. We've discussed their role in climate regulation, at least a little bit, but probably one that's really come into the interest, particularly with climate change and increasing intensity and frequency of storms in some locations, is their role in coastal protection, both in terms of, you know, holding soils together, but they offer a lot of structure with which waves have to pass, and they dampen wave energy. So this has been pretty well articulated for the mangrove literature, but also for seagrass. Megan Saunders has done some awesome work in that respect, thinking about linked ecosystems as well. And then the final point there is they're really important in water quality maintenance. So because they trap sediments, they process nutrients, that makes them important in that sense. So, and, you know, hence I think one of the last things we'll talk about is restoration of these systems for in the Great Barrier Reef, where it's not so much about carbon, it's more about trying to improve water quality for the Great Barrier Reef. So all of these things, they're linked to things like the Sustainable Development Goals. So there's a lot of interest from industry, government, you know, communities in trying to conserve and restore mangroves because of these ecosystem services. And carbon is a vehicle which can be used. So I just wanted to point out this study, just because actually a segue from before, James was talking about economics. So this is a beautiful paper that came out last year that really showed the evidence that mangroves are important in coastal protection, and it looked at economic activity using the night lights and change in the luminosity after storms. And he had two treatments, right? So they looked at places where they had less mangroves and more mangroves, and basically the time after the storm, if you have a mangrove in front of you that's at least 20 metres wide, then basically you show less economic damage than you do if you have less mangrove associated with your coastline. So and in terms of recovery, actually, the recovery is also more rapid. So there's great reasons to really focus on conserving and restoring mangroves. But we know the truth, and the truth is that they've been degraded, converted, destroyed globally. So in places like Madagascar, the top photo, they're cleared for timber. And you can see there that what's happened to the soil, actually. It's sort of receding away from those stumps as it decomposes and the carbon in the soil decomposes. They've been converted for shrimp aquaculture throughout Southeast Asia and Central America, such that mangroves, I mean, we've lost probably around 30 to 50% of the global cover. But it's not only tropical nations. The bottom photo is from Victoria, where you can see a field and the salt marsh that's next door to it. Those, hard lines between those systems where the salt marsh has been used as a rubbish dump, filled, and now has a different purpose, right? So these losses are occurring globally. In seagrass, the major factor leading to their decline is declining water quality. That's linked to the basically nutrient enrichment from agriculture in the coastal zone. So despite the fact that they're really important for for regulating CO2 in the atmosphere, despite the fact that they're important for offering all sorts of other ecosystem services, they've been declined. They've declined. So one of the consequences of that degradation is greenhouse gas emissions. Right? So we go from nice intact systems that are greenhouse gas sinks. We do things like impound them and degrade them, and convert them, and we're going to lead to CO2 emissions. And then that alternative state, that alternative land use, often is also really emits a whole lot of greenhouse gases. So in North Queensland, we've had mangroves turn into sugarcane. Sugarcane is fertilised by nitrogen, it has high nitrous oxide emissions. If it's been impounded for rice, which is the case over much of Southeast Asia, it'll have very high methane emissions. And aquaculture also has some methane emissions and nitrous oxide emissions if fish are fed. So the thing about conserving mangroves and salt marshes and seagrass is you can stop that emission and also those additional emissions from alternative land use. But with restoration, what we can do is we can restart carbon sequestration and decrease those other emissions. So we've got two options there. Conservation, where we can avoid CO2 emissions, and restoration, where we can restore the CO2 sink and avoid those emissions from the alternative land uses. Now, what we know, of course, is that carbon has a value. Now, it's not always, it has a monetary value if you can trade it in voluntary markets or compliance markets, but it also has a value in that nations have signed up to the Paris Agreement, and they are committed, we would hope, to reducing CO2 emissions into the atmosphere. So it has a value in that it is valued by governments as well, right? So that we can use that to stimulate or to provide incentives for conservation and restoration of coastal wetland ecosystems. So, you know, I've told you that they're important in regulating the CO2 in the atmosphere, but a lot of people always ask me how important. And this is from a recent review that we did for the high-level panel for a sustainable ocean economy, which is, you know, this international thing where presidents and prime ministers belong to it. Anyway, so of all of the options that are in the ocean, so we can do things like, you know, wind power and change ocean transport and stuff like that. It's sort of about, you know, 10% of that, of totally what all of the activities that could be done to mitigate CO2 in the atmosphere in the oceans, right? And it's only about 2.5% of our needs, that what humanity needs to do to reduce CO2 in the atmosphere. That's if we, you know, do conservation and restoration, we'll get that 2.5%. So somebody, you know, got on my case the other day about calling that substantial. And I had to say, you know, like, it is actually relatively small, but the name of the game at the moment is all hands on deck. And if you can get 2.5% and do all these other wonderful things for coastal communities of the world, then that is a substantial 2.5%. So, you know, it is a relatively small contribution to global mitigation. It's really important in some countries where they have low emissions in other sectors, but very high amounts of blue carbon resources. So Indonesia, a prime example there, you know, and other countries with lots of mangrove seagrasses or salt marshes. And in terms of the conclusions of this report, it is definitely high on the list of the preferred options for mitigation, primarily because of those other ecosystem services and the role these ecosystems have in climate change adaptation, right? So they not only do mitigation, but they also help us adapt to climate change, because in all of that trapping sediments and contributing their roots to the surface, they actually can keep pace with sea level rise in some instances. And Sean said something about perspectives piece in science, and, you know, this was about a sea level rise threshold of about 6 or 7 millimeters a year, which mangroves can make in, you know, they can do, you know, 5 millimeters a year, sometimes 6 millimeters a year. So that actually keep pace with sea level rise if there's enough sediment around. So, you know, in addition to that, their protection role, the way they can protect seawalls, for example, all of these things mean that they actually, even though it's 2.5%, it's a pretty great 2.5%. All right, I'll leave it there. Okay, so there's lots of incentives for blue carbon. They're growing, you know, a growing list of incentives for doing blue carbon projects, whether for conservation or restoration. And one of those first ones was the IPCC guidelines that came out in 2013, 2014. They actually gave nations guidance on how to count for both removals, so great things you do in coastal wetland space that's going to contribute to bringing CO2 levels down in the atmosphere, and also emissions. So if you do something like knock a mangrove down, you've got a way of counting it in your greenhouse gas accounts, right? So this guidance has been around for a while. There's few countries that use it, so that's still an ongoing challenge. But definitely blue carbon ecosystems are beginning to be included in the nationally determined contributions to the Paris Agreement. So these are the nation's sort of statements about how they're going to contribute to climate change mitigation. And you'll see below this picture, those countries in green are ones that have indicated that they're on their way to including blue carbon in their nationally determined contributions. So in addition to that sort of action at the national scale, there's also been some development of carbon market methodologies. And one example I've got there is the Verified Carbon Standard methodology, which gives guidance on how you can do a project to restore tidal wetlands, whether it's mangrove seagrasses or salt marshes. And in the VCS, you can receive carbon credits, which you can sell, right? So this means that the blue carbon can be kind of marketed, right? And in terms of method development, Valerie alluded to it, but we're actually working on a method for the Emission Reduction Fund at the moment, which will be about reinstating tidal flow to mangroves for restoration of mangroves. So that's a pretty exciting development. It's taken a little while, but we're hoping that it progresses rapidly. So in addition to a bunch of those sorts of incentives, there's a range of international communities that have developed that are, doing a range of different things, whether it's helping with awareness and education, whether it's helping at a nation-to-nation level to encourage the inclusion of blue carbon within the greenhouse gas accounts. That would be the International Partnership for Blue Carbon, which is an Australian-led partnership. There's things like SWAMP, which is a toolbox that the Centre for International Centre for International Forestry Research, which is all about how you go about monitoring blue carbon. And then there's things like the Global Mangrove Alliance, which also provides a forum for a community of people that are really interested in conserving and restoring mangroves, but also are interested in blue carbon. So there's a lot going on, but there's still, as always, a lot of challenges. So climate change and coastal squeeze are definite challenges for blue carbon, and poor land management and pollution and reduced river flows and these other things from the land certainly are threats to blue carbon ecosystems. Governance in the coastal zone can sometimes be uncertain, and that makes doing blue carbon projects in some places quite difficult. It still seems to be a challenge to design and implement projects that really help communities. So this is something I'm going to talk about in a moment, but just trying to make projects that work it's a really big challenge. And then finally, finance. It's not so much finance as in trying to find money that's the problem, I think, for a lot of blue carbon projects that want to occur. It's actually the right kind of finance that's the issue. So, the last thing in many ways is a big chunk of change that you have to spend rapidly, right? So it's actually about good finance for blue carbon projects. That seems to be also a challenge. So, I'm going to switch gears here a bit and talk a little bit more now about restoration and probably more about those last 2 points about doing projects that are good for people and trying to sort of generate the right kinds of funding for doing those projects, right? So I thought I'd start, the Mangrove Alliance is there again, but with there's really a big sort of international ambition for restoration at the moment, right? So the Global Mangrove Alliance has got a target of restoring 20% of the habitat by 2030. Some people find that sort of almost too ambitious, right? But we're going to discuss that in a moment for, you know, various reasons. But we've also got, you know, all sorts of other things, the Archie targets, Ramsar Convention, Sustainable Development Goals, the Bond Challenge, Trillion Trees, so on, right? So there's a whole lot of really ambitious targets out there. And I think when we first started to think about this, there's a, I didn't put the link, but we participated with Carlos Duarte in a review about rebuilding marine life. And we thought a lot about the examples that basically demonstrate restoration of coastal wetlands is totally possible, right? There's some really great examples. And probably the one that came up is the restoration of the Vietnamese mangrove forest after the American-Vietnam War. Right, so the Mekong Delta was absolutely devastated. You know, the mangroves were lost, and it was restored over decades. But you know, it might be probably one of the largest restoration projects, you know, on the planet ever. Right, so you know, there are other examples: seagrass in the Chesapeake Bay, salt marsh in parts of Europe, where you can see that, you know, technically it's really feasible, right? But we don't seem to be, doing enough of it yet. But it is sort of like the grand challenge for the next 20 or so years, is to try and really stimulate restoration in order to, one, help sequester carbon, two, provide climate change mitigation, three, provide security for a whole lot of communities that are intimately linked to mangrove forests and other coastal wetlands. Okay, so this is just some of the sorts of projects that are out there. If you go scoping, you know, these big sort of, I think this is the top left there is breaking dike wall to re-establish salt marsh in California. They like to do things with big diggers. Then the other one there is the one on the right is the managed realignment project from Europe, right? But they've been trying to do managed realignment is another, you know, word for basically, you know, letting the land go back to the sea and get or establishing coastal wetlands where you've had agricultural lands, right? So it's managed retreat, really. And then the bottom one is like, you don't have to do it with diggers in Southeast Asia. This is a picture from my colleague Ben Brown in Indonesia, where they've been restoring unproductive shrimp ponds and, you know, redigging creek and, you know, other things done by communities because they really want to restore their mangroves. So restoration comes in all sorts of different, you know, shapes and sizes. So the next few slides are basically a set of issues that restoration has in the blue carbon with respect to blue carbon, right? So issue one I can see is that blue carbon restoration projects offer less mitigation than those protection projects. And that's because if you do conservation, you can avoid emissions of very large carbon stocks. You know, they're one-off front-end payments that if you can, you know, sell it, that can really, you know, be very, very productive in terms of avoiding emissions. So the example down the bottom is if you clear 1,000 hectares of mangroves in Indonesia, you're going to probably give rise to about 2.5 million tonnes of CO2, which might be worth about $30 million if you have a fairly, you know, $12 a tonne carbon price, right? And you have to balance that against a restoration project that if you restore 1,000 hectares of mangrove, you get 4,500 tonnes a year, right? So it's actually much less, and the payments are going to come incrementally. All right, so restoration and blue carbon, you know, it's not necessarily an awesome fit, you know, and that is particularly in view of the fact that blue carbon project establishment costs are high. And I would say that under the VCS, where I know it's about $80,000 US to register and verify a project, right? So this can be quite difficult, and this is for 1,000 hectare project that I'm talking about, right? So that's issue number one, right? Actually, for blue carbon projects, it makes better sense to restore than to conserve than restore. So probably the issue number two is that costs of restoration can be quite high. And we know this from the lovely work that Alyssa Bayraktarov and others did, Megan Saunders, that, documented or, reviewed the costs of doing marine restoration. And I've got a picture here of seagrass. This is from Western Australia, from our colleague John Statton. It's a gorgeous sort of project where he's really trying to work out, it's like trying to work out how to do the the technical part of getting these seagrass seeds to sink, so they float and they have to lose their seed coat before they sink, right? So if you're trying to, seed seagrass projects, you have to do quite a lot of investment, right? And so continuing on this work, I've got Phoebe's name there. She's doing more in this sphere. Probably the other thing is that Alyssa identified is that projects are typically small, right? So when the costs are high and the projects are small, and we just looked at the potential returns, you can see that there could be a problem of these sorts of projects not being really worth it, right? So the solution there would be to go big, right? Let's have big projects. But big projects, are very risky. And the evidence is that there's actually very high failure rates in large mangrove projects. And there's a nice study from the Philippines by Eugene Primavera that showed actually the larger the project, the higher the per hectare cost was in the Philippines. And, these are sort of like large infrastructure projects, and they're basically prone to corruption, right? So the bigger you go, actually, you take on some risk. The other thing is the bigger you go, usually the government's involved and big money's involved, and that means that the community is less engaged often, right? And that has, negative impacts for communities, but it also has negative impacts for the long-term sustainability of the project if those community members are not really engaged in the process, because if there's been over-exploitation, there will continue to be over-exploitation of the mangrove. So there are some really big projects though, and some of them are quite controversial. So there's a project in Senegal, which is somewhere between 7,000 and 10,000 hectares of mangroves. There's a really big area that is, available for restoration because of a total disaster in the Delta with the building of large dams and drought, which basically killed, resulting in the, death of the mangrove forest, villages, no more fishing resources, so all of the men have to go away, that kind of stuff. So there's really good interest, there's really good reason to want to restore those forests, but there's, it looks great if you look at the website, but there is, if you dig into the literature, dissent. There's not so much equitability and sharing. There's just a whole range of issues. Okay, so that's issue 3. Big projects are risky. Issue 4, though, is that small projects might not deliver landscape scale benefits. For a lot of these projects, it is coastal protection fisheries, and that are the co-benefits that people are after, and they require large connected ecosystems. So, that's a bit of a problem. If we're going to do this, we've got to line them all up if we're going to do a lot of small projects. And the other, interesting thing about small projects is that big money. So if we go to things like blue bonds or the, Global Environment Fund sort of scale of money, this is like over projects that are less than $2 million, they're really not interested in, right? So, trying to find a sweet spot is actually quite difficult for some of these projects. Mangroves and salt marshes and seagrasses are fringing. You know, they're often linear features. They're, you know, while that Amazon forest can, you know, you can find large continuous blocks. In mangroves, it tends to be spread out, you know, like over coastlines. It's actually, finding large projects is actually quite difficult sometimes. And then from me, finally, this is my issue number 5, community needs. If you put ecosystems into carbon projects, often it results in limited access to people who want to collect firewood and go fishing. And this becomes an issue, or, you know, that really depend on those resources. And this becomes an issue where you have a lot of landless people who cannot contribute, who don't have land on which to, you know, participate in such a thing as a carbon project, right? So I suppose you see that when you're doing conservation as well. I know in Myanmar there's a big project to make a large marine protected area that's being pushed back by the community, because basically they know it's going to restrict their access to resources. And from my work in Myanmar, I'm actually really sympathetic to the people who want to collect crabs and sell firewood. And you can see this woman, this is often falling to women, she's selling these little bundles of firewood, because in Myanmar that's all people have to cook with, right? There's no gas and there's no electricity. So the mangrove is the resources, right? But in more developed nations, it's about providing the right kind of incentives to consider restoring what they might be, you know, under cultivation for some kind of commodity, whether it's sugarcane or aquaculture production, right? So there is this issue that all of these projects have to sort of meet community needs. Carbon is kind of like nothing, you know. You know, we breathe it, and it's sort of everything, but it's not something, you know, a farmer from Myanmar necessarily thinks they need to do anything about, right? So it's about addressing these community needs. So I think if you put all those 5 issues together, you come up with the idea actually that not one size fits all, and basically we're going to need a very sort of like diverse kinds of projects, restoration projects, if we're going to do them for blue carbon. And I think that just sort of matches that variation in biophysical and socioeconomic contexts throughout the biome, right? So not everything is the same. So we, you know, maybe the design of blue carbon restoration projects should be as variable. So this is a lot of text here, but I just wanted to give you a brief, you know, look at addressing some of these issues. But before I go on and talk about some real restoration projects, right? So there's a couple of things we can do, right, just in general, is reduce the costs of restoration. This is a big one. So there's technological innovations, that's important. Things like, you know, working out how you can plan for projects without, in places where you don't have great digital elevation models, for example. We really got to reduce the administrative costs. And I put Nikki's name there because she's doing a project with the Nature Conservancy at the moment, looking at permitting and reducing the sort of like the time and burden to do restoration projects. But in addition to that, there is these, you know, how are we going to reduce the cost for small projects such that they don't have to pay $80,000 to register and verify a project. So maybe one of those solutions is bundling projects. So spreading the costs, building different kinds of larger projects by joining them up. And I think they're, you know, land use planning is also a really important component of that piece. And then, you know, reducing the costs of monitoring and verification are also really important. And that's all about building methods that are actually relatively easy to follow, robust, but relatively easy to and inexpensive to kind of operate. So we also want to increase the benefits. So more than just carbon, and I've got a slide at the moment from work that Valerie's done in North Queensland. We're going to need more equitable projects, and I've got Sang Fan's name there. He's the coordinator for the project in Myanmar and has been thinking a lot about how to do community forestry in the right kind of way. Land use planning, we're going to have to link up smaller projects and MPAs to get the sort of like the benefits that we're going to need. And then finally, we're going to have to introduce the impacts of climate change, whether that's choosing smart places to do projects or taking on the sort of like the floodplain and management of the floodplain in a way that allows landward migration of these ecosystems with sea level rise. Okay, so now we can go on and talk about some of the fun stuff, which are projects. I don't know whether any of you have heard about this one. This is called the Blue Heart. It's got a great name, right? Launched last year by the Minister and the City Council and the water utility that jointly are doing this project. So I think this has got elements of the perfect big restoration project. A lot of, you know, government involvement. They already own the land. It's going to be, I think, in its when it's complete, about 5,000 hectares, and it's being restored, you know, largely for flood control, and you know, restoring the wetlands basically reduces water flow rates and enhances infiltration. It's also important for nutrient treatment on the Maroochy River. And importantly, it's really supported by local Indigenous communities because the Maroochy River is so important. And then the other benefit is because it's a site that's owned by government, they're also planning to do a whole lot of recreational activities associated with that. So trail and bird hides and bird watching and other things, right? And then the final piece here is it's actually a pilot blue carbon project for the state of Queensland. So in many ways, I really hope in the end that the, you know, carbon piece of this sort of gets off the ground. But I think this one is, you know, it gives you, I think if you're going to do a big, sort of a big project, you know, more than 1,000 hectares or to 7, then I think this one is a really nice example of how you might bring something like that together. It's still under development, right? But, it's a nice example where currently working out, you know, how to measure soil carbon accumulation and other things in this site. So the second one I want to talk to you about is actually, well, it's actually, I'm going to give you a slide about Valerie's work, but I'm going to talk first about the Land Restoration Fund. So the Land Restoration Fund is a commitment from the Queensland Government to do carbon farming that deliver co-benefits. In the first round, I think we're on to the second round of projects now. So this is also sort of like an interesting model of private public partnerships, and it's not huge money, right? But it's providing enough to get pilot projects off the ground. So we have one of these pilot projects. It's for a site up near Innisfail, but I can't really talk to you about it except because it really hasn't started. And that's because this is the challenge up there, is actually finding landholders who really want to do a project that releases agricultural land back to the tides, right? Because, you know, everything has been, well, a lot of land has been, you know, bunded and drained, right? So there's a lot of nervousness about enacting those kinds of projects. But what I did want to talk to you about this is the economics of restoring some of this sugarcane land in the wet tropics. And this is fantastic work that Valerie's done. And this is just a short version, and I hope that she'll be able to give us a full seminar on this. But basically in the wet tropics, she identified about 5,000 hectares that are going to be profitable for restoration, you know, under a carbon project, right? But the interesting thing is that it's not just carbon in the soil that's accumulating in the biomass, right? Well, a really important part of this was those avoided emissions that I talked about at the beginning, nitrous oxide and methane, right? So, you know, without that, it really doesn't look that economically viable, right? There's very few sites that would be available. So she also identified that areas suitable for restoration can be doubled if you have, if you count, you know, additional benefits. So things like for fisheries and nutrient treatment and biodiversity, and also with higher carbon prices. So most of her work was done with the Australian government carbon price at the moment, which is about $12 to $13 a tonne. But some projects, like the savanna burning projects in Central Australia and across the savanna regions of Australia that are done by Indigenous communities, receive $25 a tonne. That really makes a difference to how attractive these kinds of projects might be. But currently, we really don't know what the cost of establishing these projects is going to be, like, you know, counting the carbon. And that's really contingent on what the methodology really looks like in the end from the Emission Reduction Fund. And then I think this is my final slide, or close to, and this is about restoration of mangroves in Myanmar. So in this situation, the government owns most of the forest and it can't protect it, right? So what we've seen, if you look at that top right picture, is, you know, the purple stuff was mangroves lost in the 70s. The red stuff was lost in the 90s. The yellow stuff is lost in the 2000s. And what we've got left is the green stuff in 2011. And I can tell you that some of that green stuff is not in great shape either, right? So, you know, a cyclone, a huge cyclone, hit this site in 2008 and killed 170,000 people. And so the government is very motivated to try and restore the mangrove. And you can see a mangrove planting down below on that right side. But, you know, despite this incentive that they have and also their efforts, the forest is still declining, right? So community forestry is really one of the things that's a proposed solution here, because so basically taking the forest out of the government's hands and putting it back into the communities who can defend it. But if they do kinds of, you know, the standard sort of community forestry project, they basically lock out the landless people in the Delta. And in only our 3 little villages that we work in, or 3, you know, village tracts, there's like 200,000 people who collect stuff from the mangroves who would not be included, right? So St. Fan's been doing a lot of thinking about how to make common woodlots, mangrove woodlots, to support extraction, and also how to do aquaculture and mangrove silviculture at the same time. So in these situations, it's really about livelihoods, right, and maintaining livelihoods. So this is the second to last slide. So what are my conclusions? Restoration of coastal wetlands at scales needed, and there's a lot of ambition globally, but there's a lot of uncertainties around blue carbon restoration projects that need more work. So, you know, like, we're on it, and with, you know, Valerie and others in the linkage team, we're really trying to think about how to make it happen. And my guess is that basically we're going to need a real diversity of approaches for a really diverse set of settings. So thanks to a bunch of people who, or a bunch of institutions who provide resources for this research. So with that, I'll stop, and thank you all for listening.